Hi guys, how are you all?
Good. How are you?
Good. Did you guys have any questions on the homework?
No.
So we did translation. Okay. We didn't do dilations, right? Okay. How are you, Pranav? Pranav, what are they doing in school?
I'm doing transformations.
Oh, that's nice. Arya, Sricharan, how about you?
Wait 1 minute.
What are you doing in school, ma'am?
Yeah, we're doing probability.
Oh, you're doing probability. Is it easy? Are you using what we did in here?
Yeah.
Okay. Is it easy?
Oh yeah.
Devansh, what are you doing in school?
We're doing I forgot functions and functions. That's what we're still doing.
Functions. How about you, Srishta?
We're doing probability.
Oh, probability. Is it easy, ma?
Yeah.
Anything that we have not covered is coming through, or anything that is difficult for you there?
No, it's everything we've already done in class.
So it's easy, meaning are you finding it easy there?
Yeah.
Shruti, how about you, ma?
We're also doing probability.
Is it easy for you?
Yeah, it's really easy.
Okay, how about you, Krishav and Vihan?
I'm
First, let
doing
me ask
like
Vihan.
percentages with taxes and like tips.
Okay, taxes and tips that will come. Okay, so is it easy? How about you, Vihan?
We're doing like graphs and then mean, median, and mode. So like,
That's something I want to come to, but not right now. Next thing I want to cover is statistics. Okay, that will go in depth more than what we covered in sixth grade. They'll cover box whisker plots, comparisons, and stuff. I'll come there, but not right now. Okay, after I finish transformations, I'll come there. Okay, Jashwita, what are you doing in school, ma?
We're learning pi.
Sorry, Jashita, what was that?
We're learning pi.
Pi?
Yeah.
Okay, how about you, Netra and Johan? Give me a
We're
little heads up on what you're doing in school.
we're doing volume of 3D figures, like all of them.
Dot plots.
I see. I see. Okay, dot plots. Okay, that's fine. But I have a question. Did we do 3D already or we didn't do?
Yeah, we did.
We did 3D. Okay, yeah.
Yeah, before we did translation.
Okay, that's nice. That's nice. Okay. Okay, let's go over. What did we do the other day? We did translations, right? Okay, any questions in the homework, guys? Any questions on the homework?
No.
No? Okay. Okay, section 1 transformations. You know what? But I did not do anything other than translation, right? Yeah. Okay, let's see. Let's review quickly. Okay, I didn't do rotations and dilations. I know that. Okay, let's see. But I did. Did we do reflections last week?
Yeah. Yeah.
Yeah, we did.
Okay. How about this? Okay, how about this? This one is a good one. Okay, let's review this quickly. You're going to help me answer this. Let me see. Can I share my screen? Go ahead. For some reason, I'm not able to paste it. Why, guys? Wow. 1 second, guys. I don't know what is going on. Yeah, but why am I not able to paste? 1 second. I don't know why I'm not able to paste. Let's see. Yeah, that's better. Okay, let me share my screen. I can do this one quick. Can you send the answer in chat, guys? It's just what we did last week.
Can you text me?
Sure. Oh wow. Okay. So Krishav, you want me to message you? Arya Sricharan, what did you say you're doing in school?
We're doing probability.
Okay. Is it easy, Arya Sricharan?
Yes. Yes.
Krishav, is that right? Reflection on the y-axis, right? Bihan, that's right. Pranav. Why are you switching, Pranav?
Oh, my bad. I know the answer now.
No, Netra correct. Arya Sricharan correct. Sreshta correct. Indian correct. Shruti correct. Now, can I get answers from Johan? Netra, did you send?
I already sent a long time
Yeah.
ago.
1 second. Oh, yeah, Johan. Sorry, Johan. Correct, Srihari. Johan correct. Ishan correct.
You said I was correct.
Yeah, Netra, I'll check. Naman, good
Wait,
job.
can I use the restroom quickly?
Yes, Netra. Yes, Ma, you can go, Vihan. Okay, guys. For those of you who did not understand, right? See here. Let's say I have a point 2 comma 3. Okay. You reflect it on the y-axis. What happens if you reflect it on the y-axis? Devanshu, tell me what will be the point if you reflect it on the y-axis? Devansh, tell me the point if you reflect it on the y-axis.
It will be negative x.
Negative x. So if you reflect it on the y-axis, what gets negated? X value gets negated, right? If you reflect the same point on the x-axis, what happens? What will be the resulting point? It will
Me?
be
Oh, it's negative y. Yeah.
2 comma minus 3. So the y value gets negated. See, if you reflect it on the x, Jashwita, are you sending the answer or did you not get it? Where are we, ma?
I already sent the answer.
For some reason I did not. How are you doing in school, Jashwita?
I'm doing good.
Okay. If you reflect it on the x-axis, your y value is negated. So if I give you a point 5 comma 3, okay, reflection on x-axis means if you reflect it on x-axis, your y value gets negated. Suppose if you reflect it on the y-axis, what happens? Your x value gets negated. Any questions here? Okay, now let's go ahead. Okay, let's go ahead and look at this line. What happens to this line? Let's consider the same point. 2 comma 3. Now I have a question, guys, before we move on. What is this line? What is the equation of this line? What is the equation of this line? Tell me, guys.
It's proportional.
What is it?
Y equals X.
Y equal to X. This line equation is called y equal to x because look at the points 0 comma 0, 1 comma 1. This is 2 comma 2, right? But I don't want the 2 comma 2 point. Wait. When you consider this line, right, the points are 2 comma 2, 3 comma 3. So do you see 1 comma 1, 2 comma 2, 3 comma 3? So this line is called y equal to x line. The equation of that line is y equal to x. I want Ishan to tell me what is the equation of this line, Ishan? What is the equation of that line, Ishan?
Negative y equal to negative x.
Is it negative
Oh,
y equal to,
or y equal to negative x.
y equal to negative x. Good job. This line is called y equal to negative x. This line is called y equal to x. So reflections on these lines are also very popular. Okay, suppose I have a point 2 comma 3, 2 comma 3. Suppose if we have the point 2 comma 3, suppose if I reflect this point on the line y equal to x, what will happen? Who can tell me?
It'll become 3 comma 2.
3 comma 2. How ma? This is 2 distance, right? Yeah. So why do you think it will happen?
Because y will be equal to x, so your y value will become x.
Yep. So it's like the x distance horizontally you're moving okay, from your origin you're moving up by 3. This is up by 3, right by 2, correct? So if you reflect it on that line, right, if you reflect it on that line y equal to x, it just gets changed. What gets changed? You will move this many units up, you'll go this many units up and this many units to the right, 3 units to the right. Makes sense, meaning this is right up, this is right up becomes up right. Makes sense, guys? It just gets exchanged. X comma y point, when it gets reflected on y comma x, becomes y comma x. Okay, here see, they both get interchanged. Now if you reflect it on the point, let's say we have the point 1 minus 1 comma 2 minus 1 comma 2. I'm going to reflect it on the line y equal to minus x. What will happen to the point minus 1 comma 2 if it gets reflected on the line y equal to minus x? Who can tell me?
It'll become negative 2 comma 1.
It will become, yeah, it will become negative 2 comma 1. So it, see, you go up by 2, left by minus 1, right? So it gets interchanged, meaning you go left by 2 and then up by 1. So that becomes minus 2 comma 1. So x comma y point becomes what? X comma y point becomes
Negative y comma x.
negative y comma.
X.
Is that so?
It's negative x.
Negative x. See, this one they get just switch. Y equal to x line, you just switch. Here, switch and negate. Any questions, guys? Any questions?
No.
Okay, at some point you need to memorize this. There is no other go. Okay. Okay, let's see. Let's see one or two more questions and then I'll go. So we have learned reflection on x axis, y axis, x equal to y and y equal to negative x lines. How about this? Okay, how about this? Okay, you are going to send me a dash, b dash, c dash. Find out a dash, b dash, c dash. This is just straightforward. Try, guys. Go ahead, guys. I want the a dash, b dash, c dash 3 points. Let me know if you need help.
Wait, Miss P, is this along the x-axis or the y-axis?
This, Amma, this is reflected on the line x equal to y, right? Does that make sense?
Can't really get. I mean, how do you do it if it's x equal to?
Why? Were you there when I explained it just now?
Yeah, I mean, I wasn't there for like the first part because I went to the restroom.
Okay. Where are we not understanding? Okay. Vihan, this is my x equal to y line, right?
Yeah.
Consider the point 3 comma 1.
Yeah.
Okay. If I reflect it on this line, what happens? Meaning this is 3 right, 1 up, right? if I reflect this point on the y equal to x line, right, meaning this is 3 right, 1 up from the origin, always see the reflection on the y equal to x line, right, when you're thinking about it, I always find the distance of the point from the origin. Okay, now 3 right, 1 up, correct? So that switches. How does that switch? 3 right becomes 1 right, 3 up. So that becomes 1 right, 3 up. So what happens, you see? 1 right, 3 up. So the point becomes 1 comma 3. Makes sense? So what is the transformation for x comma y point? If it is reflected on the line y equal to x, what will be the transformation of the point x comma y?
Y equals X.
Yeah, meaning see, if x comma, if the point x comma y is reflected on the line y equal to x, what will be the transformation?
Y to X.
Yep, they just get switched. You got
Yeah.
it?
Yeah.
Whereas if it is reflected on the line y equal to minus x, how does it work?
Then it would be X equal to, I mean, no, negative X equal to negative Y.
X comma y becomes what? Okay, let's find out. Let's find out one more time. Please, those of you who didn't catch up, you can catch up now. So the point, this is minus 1 comma 3, right? If I reflect it on the y equal to minus x line, it's just the same thing. 3 up, 1 left. 3 up, 1 left. So what happens if I do the other way? Meaning, if I reflect it on the line y equal to minus x, it'll go 3 left and then what?
One
One up.
down. Yeah, one up. Yeah.
1 up. So what happens?
Then it would be negative 3 comma 1.
So how does it change? X comma y, how does it change?
Oh, they just no, wait. You flip the numbers.
How do you say that? For this line, they just swap, right?
Yeah.
For this line, they swap and negate. Make sense?
Swap and negate means that.
Make sense?
Yeah.
So the x comma y line becomes minus y comma minus x. Swap and negate. Make sense?
Yeah.
So now do you understand how to do this question?
Yeah.
Come on, let's see the answers. Go ahead, guys. Okay, did you get it? 4, 1, 2, 3, 1, 5. Srihari, is that right?
Yeah, it was reflected across the y-axis, right?
Y equal to x, right?
What?
It was reflected on the line y equal to x, right?
That means x-axis, right? Or it means x-axis?
It's not the x-axis, right, Srihari?
Wait, so
Let me see. This is the x-axis, right?
yeah. Uh-huh.
This is the y-axis, right?
Mm-hmm.
This is the line x equal to y, right?
Mm-hmm.
This is the line y equal to minus x, right?
Uh-huh.
These are the lines of reflection that we have studied. If
Yeah.
x-axis reflection x comma y becomes what negates the other coordinate negates x comma minus y. Suppose if it's reflected on the y-axis, x comma y becomes what x coordinate negates. Make sense?
Yeah. Thought I did.
Now, if it's reflected on the line x equal to y, right? What happens? They just swap. You see what I mean?
Oh, okay.
Y equal to minus x, x comma y becomes swap and negate. Make sense?
Mm-hmm.
Swap, negate. This is how you remember. Similarly, x-axis means y negates. Y-axis means x negates. Any questions?
No.
Wait, negates mean it becomes negative?
Yeah.
Okay.
That x coordinate, see 2 comma 3 becomes minus 2 comma 3. You got it? Did you get it?
Yeah.
Okay. Can I move on? So here they just switch. It's very easy. A dash is 4 comma 1. Always the dash is used for image points. This is the pre-image points, right? B dash will be equal to 2 comma 3. C dash will be equal to 1 comma 5. Any questions, guys? Okay, now let's go ahead and do this one. How about this? Let's consider the last one. Not the last one. We have dilations too. How about this? Suppose I have this block of wood. Okay. Now, for reflection, we had a line of reflection, right? On that line only act as the mirror, right? So, for reflection, we always had lines of reflection. For rotation, we will always have a point around which it rotates. Point of rotation. We will have a point of rotation. Now, what is this point of rotation? For you in 7th grade, we will have only one point of rotation, the origin. We are not going to study the rotation around any other point. That you'll study in geometry. It's a little bit complicated. Now we are only going to study, we are going to rotate objects around origin. Now this rectangular block, I want to rotate 90 degree counterclockwise. I want to rotate 90 degree counterclockwise. So let's say this is 0, 0. This one is 3, 0. So what would happen to 3, 0? What would happen to the point 3, 0 if it is rotated 90 degrees? See, draw this line. Draw this line. If it's rotated 90 degree counterclockwise, what would happen to that point? Who can tell me?
It would be 0, 3.
Yup, we will see this line will itself be rotated 90 degree counterclockwise. So what happens? That point goes here. So 3, 0 will become 0, 3. Any questions on that? Any questions on that?
No.
So what happened here? The x point, right, got switched. Did you see that? Did you see that?
Mm-hmm.
Now, as a next step, let's consider this x comma y point. Okay. Now, I'm going to rotate that 90 degree counterclockwise. What would happen to that point, Jashwita? If I want to rotate this point 90 degree counterclockwise, what would happen to the point?
It would become a negative 3 and 0.
Aha, good. It would become negative 3, 0. So what happens to the y? See, x coordinate went and sat in the y place. But if you have a proper y coordinate, what is happening to that? The y coordinate goes to the x place and sits down, but then it also, guys, 3, 0 becomes 0, 3. It's a proper x coordinate. Suppose if I have 0, 3, a proper non-zero y coordinate if you have, then it becomes -3, 0. Now if you have a proper x, proper y that's not a 0, then what would happen? Tell me. See this and tell me. Who can summarize?
They would swap.
Yeah.
They would swap, but something else is happening too.
They're changing negative, like to positive.
Yeah, which one? Not
Um,
both, right? We are only doing 90-degree counter. Rotation is the most difficult one. You're rotating
X would be
90 degree.
negative.
Huh?
X would be negative.
Good. So how to write that down?
Negative X.
I mean, X would go to
X would go to Y. This X goes and sits in Y. Okay. And then Y would become what?
it would be in the X value.
Yeah, but how to write that down?
Y.
Y would become?
Y would become negative.
Negative Y will go and sit in the X position. Make sense?
Yeah.
So how do you remember this? Okay, when it's 90 degrees, see, we'll start with one by one. Always we start with the counterclockwise direction, 90 degree. When you start with 90 degree counterclockwise, what do you say? Swap and negate. Swap and negate. Make sense? Does that make sense?
Yeah.
Yeah.
Okay. Now, if the same, okay, think about this, guys. Rotating 90 degree, so this block, what happens? We did not finish discussing this block. This block, right? You said this line 90 degree, find the 90 degree counterclockwise turn. So it goes here, right? And after that, let's see what happened to this. This also, the parallel line also goes like this, right? And then what happens? This is this is this. Make sense, guys? This is 90 degree. See, for this line is 90 degree. Do you see? And then this line, how is this line rotated? This line 90 degree counterclockwise means it rotated 90 degree counterclockwise and came here. This line, the perpendicular line to x-axis, became parallel to x-axis. Make sense, guys? So 90 degree counterclockwise can be summarized as x comma y. What happens? It definitely switches, right? It definitely switches y and x. But then one important thing what you need to do is negate the y value. Make sense? Can I move on? Let me write down 90
Miss
degree.
Priya, can I go to the bathroom?
Yeah, ma. X comma y will become minus y comma x. Now let's consider, what is this, guys? You're rotating 90 degree counterclockwise is the same as when you rotate the same thing clockwise. What is it called? How much degree is it?
270.
270. Good job, Naman. 270 degrees. So whenever you say counterclockwise, there is always a corresponding rule for clockwise. So 90 degree counterclockwise is the same as 270 degree clockwise. Any questions?
No.
They both have the same rule. Make sense?
Wait, so does that mean that it could be the same thing? So 90 it could be 270 counterclockwise and 90 degrees clockwise.
Yes, yes. So when you memorize the formula for one, it's that you've memorized for both. Does it make sense?
Yeah.
Okay, now let's consider one more. Let's see one by one. Okay, but this you need to memorize. There's no other goal. Let's see. How about I want you to understand this one. Now you have this point. 1, 2, 3. 1, 2, 3. Now let's say you have this point. I want you to understand how. I don't know. Let's say, okay, 1, 3. Okay, this is 3, 1. Now I'm going to see. This is my point. My point of rotation is the origin. So I will draw, like, I will use a stick. Okay, from the origin to that point, I'll use a stick. That is what I'm going to rotate 180 degrees. Think about that. You see, the stick is what. That's why we say this is the point of rotation. Point of rotation is the origin. Okay, not any other point. That's what makes it easy. So always draw a stick from the point of rotation to your original, the point you're rotating. Now that stick, I'm going to rotate 180 degrees counterclockwise. 180 degrees counterclockwise I'm going to rotate. What would happen? What would happen to that point? Who can tell me what would happen to that point?
Both x and y will become negative.
Wow, nice. Okay, so let's see, wait. So we are going to rotate it 180 degree counterclockwise. Okay. Now what will happen to x, ma?
X will stay the same, like the same number, except x will become -3.
Good. X will become -3 and then?
Y will become -1.
So what is going on then? 180 degree. For
You're
180.
just making both x and y negative.
Do they switch?
No.
Good. So that becomes -x, -y. Does that make sense? Guys, Johan, does it make sense? Okay. Suppose 180 degree counterclockwise. If I'm asking x, y becomes -x, -y, meaning they just negate both. Okay, switch and negate y. Make sense, guys? How about this 180 degree counterclockwise is the same as what other rule? Who can tell me? Jashwita, Krishiv, Vihan, who can tell me? Or Netra, who can tell me? 180 degree clockwise is the same rule as what?
80 counterclockwise.
What is that?
It's the same as 180 counterclockwise.
Yes, the same. 180 degree counterclockwise is the same as what? 180 degree
Clockwise.
clockwise. So for both, it's just the same rule. You got it, guys? So what is the missing one that we have not dealt with? We dealt with 90 degree counterclockwise. We dealt with 180 degree counterclockwise. What is that that's missing?
270.
270?
Counterclockwise or
270 degree counterclockwise. If it is 270 degree counterclockwise, let's find that out. Wait, guys. I'm going to talk about 90 degree counterclockwise. This is 180 degree counterclockwise. 270 degree counterclockwise. I'm going to rotate 270 degree counterclockwise. So let's say there is a point. What is this? Let's say 3, 1. If I rotate it 270 degree counterclockwise, what happens to that point?
I think
This line is what I'm going to rotate 270 degrees. So that line becomes what?
-3, comma
-1.
It
Comma
will become,
-3.
what is it?
1, -3.
One second, guys. I make a mistake.
Can I go to the restroom, Miss Priya?
Yeah, ma. So a proper x value when rotated 270 degree counterclockwise, what would happen to that proper x value?
Y value.
The X and Y switch, the like now
It'll
thing
swap and become a negative.
Very nice, but you cannot generalize that. Hold on. Now 3
Oh, I
comma
can
0, a proper x value becomes this. So what is happening to the x value?
so I think the formula was y comma negative.
Let's not hurry for the formula because we
Right.
don't have the y value here. Okay, don't worry about it. A proper x value becomes what?
It becomes the Y value and it becomes negative.
Yeah, it becomes the y value but negates. Good job. Now let's consider 0 comma 3. 0 comma 3, I'm going to rotate it 270 degree 270 degree counterclockwise. That is, this is 0 comma 3, right? A proper y value. What happens to that y value if you rotate like that?
It becomes the X value.
Exactly, it becomes 3 comma 0, right? So a proper y value would become what? A proper y value is becoming what?
It become an X value.
Exactly. So it switches. So see guys, in 90 degree clockwise, x comma y will switch, and what negates? The y negates, right? It will switch, but the y negates. Similarly, in 270 degree counterclockwise, what happens? It switches, but what negates? X value negates. So 270 degree counterclockwise, how can I write x comma y becomes y comma minus x? Did you get it, guys?
Yeah.
It's the same as what? Same as what rotation? 270 degree counterclockwise is the same as what rotation?
90 degrees clockwise.
Yeah. You all got it, guys?
Mm-hmm.
Is it easy? Ma, please, yes, you'll have to memorize, no doubt, okay? But if you don't remember, right, it's okay, you can derive it. How can you derive it? Put nice points. Put nice x, 0 y. Then you see what happens to that x value when you rotate it. Then put a nice y, put a 0x, see what happens to that y. Then combine both, right, for x comma y rotation. Does it make sense, Jashwita?
Wait, Miss Priya,
Yeah, go ahead.
what do you mean by nice y and nice x?
Non-zero.
Oh, okay.
I assume 3 comma 0 x and y. I rotated it and found out how the x changes.
Okay.
Then I assumed 0 comma 3 with a non-zero y and saw how the y translated, y transformed, and used that for y. You should use non-zero x and y, right? But for me, visualizing both at the same time is difficult. So when I learn it, first I will learn, okay, I'll put x comma 0, see what happens to that x. And then I'll put 0 comma y, I'll see what happens to the y. And then combine both the rule for x and y. Does it make sense, Srihari?
Yep.
Arya, does it make sense?
Yes.
Okay, so the formula, these things you need to memorize. X comma y becomes minus y comma x. X comma y becomes minus x comma minus y. 180 degree counterclockwise is the same as 180 degree clockwise. 270 degree clockwise is the same as 90 degree counterclockwise. So there x comma y becomes y comma minus x. Can I move on, guys?
Mm-hmm.
Okay. So for reflection, there is always a line of reflection. For rotation, there is always... For rotation, what do you have? Line or a point?
Point.
Yeah. So how do you visualize rotation? Suppose you have this point 3 comma 1. What do? From the origin is your point of rotation, I draw a stick. That stick only rotates. Suppose if you want to visualize, hey, I rotate this point 90 degree counterclockwise. If I say that, what do? You know, this stick you start rotating it. Okay, where is my 90-degree rotation? Here, right? Not even there, hold on. My 90-degree rotation point is here. So what is that point? You see, this makes up 90 degree, this one, this rotation, that stick, right, from the origin, right? 90 degree, I rotate it counterclockwise. If I rotate it 90 degree counterclockwise. So it goes and sits here. When I saw, well, how do I do that? X comma y becomes, see, x comma y becomes, what happens here? Three comma 1 will become what? Minus 1 comma 3. That means minus y comma x. Did you get it, guys? Pranav, did you understand that?
Yes.
Okay. Now, the same 3 comma 1 point, if I rotate it 270 degree counterclockwise, what happens, Pranav? 270 degree counterclockwise, I have to rotate.
Goes all the way around.
Yep, that, see, that stick,
Oh,
draw
back
the
to
stick,
one.
that comes here, right, Pranav? So where does it come?
It'll come to negative
See, this is positive, this is negative. So
3, 3 negative 1.
Negative?
3 negative 1.
Is it 3 negative 1?
1 negative 3?
What do you think?
Oh. Because
What do you think, Pranav?
1 negative 3 because it comes
1
on
negative.
the axis.
Yes. So that x comma y point becomes, y comes here, but x negates. Makes sense? So here actually both switch. Okay, in both the cases they switch. But y negates here on the 90 degree counterclockwise. X negates on the 270 degree counterclockwise. Counterclockwise only you will study first. Okay. After that, clockwise is very easy. You can, this is 270 degree counterclockwise is the same as 90 degree clockwise. Here 90 degree counterclockwise is the same as 270 degree clockwise. Any questions here, guys? Did you all get it?
Yeah.
How about this? As I said, right, translation, rotation, reflection are all called what? Rotation, reflection. In all of these, the image is the same as pre-image. Image and pre-image are congruent, right? Pre-image means the before point, the transform point is the image. They are congruent, meaning their shape or size does not change, correct? Meaning, suppose if you have a triangle, right? This triangle size does not change or the shape does not change if you translate, rotate and reflect. Any questions on that? So, since the image is congruent to their pre-image, these three are called rigid transformations. Any questions? They are called rigid transformations. Can I move on? Indian, did you understand that? But there is one exception. Suppose I have this triangle. This is 1 comma 3. Okay, I have this triangle 0 comma 0. Okay, now we are going to study something entirely different. You know what is dilation? If you go to an eye doctor, he dilates your eyes, right? What does he do? What will happen when you dilate your eyes?
Makes them bigger.
One way of looking at it, yes. Good.
Wait, why did they do that?
Why
did they do that?
Why do they do that? They drop some, see, many a time when you go to the eye doctor, right, to check your power, right, they dilate your eyes, meaning they make your pupil bigger so that they can see if there are any issues with your pupil. If your pupil becomes bigger, they can look better, meaning when they look under their equipment, your pupil, when it appears bigger, then any issues can be detected with ease. As is your original pupil, it's very difficult to detect if there are any issues. So what they do, they put some drops in your eyes, let you sit for 1 hour. That is the old way, that is the old school way of doing it. Okay, so what happens in those 10 minutes, the chemistry, the drops, right, that is put in your eyes, right, slowly makes your pupil bigger and bigger. Then when they see your eyes in their equipment, right, your pupils are so large and they can detect if there are any problems in your eyes with ease. So here in the eye doctor case, it enlarges. Okay, but dilation doesn't always mean it is enlarging. It can also reduce the shape. Meaning, suppose if I have this triangle, if I make it like this, or if I transform it to this, or if I transform it to this, both mean dilation. Don't get confused. Both mean dilation. But this one is called enlargement. This is, I'm sorry guys. This is called enlargement. Why I'm not able to write it there? I don't know. Okay, I really don't know. When you make, see, when your image is bigger than your pre-image, right, that is called enlargement. When your image is of a lesser size than your pre-image, that is called reduction. Any questions, guys?
Miss Priya, you're not writing anything.
I am writing. I know you're not seeing, huh?
Yeah.
I know why that happens. Okay, I'll rectify that. Yeah, I do see that you're not seeing it. I don't know why it is like that. Let's see. So basically, the dilation can be making it bigger, or making the original image smaller. If it is making it bigger, it's called enlargement. Now you're able to see, Vihan?
Yeah. The bigger part came, and the smaller part just went away.
Still, huh?
Yeah. Yeah, it's not coming down.
Okay. You're able to see reduction and dilation, reduction and enlargement?
Yeah.
Okay. So dilation can be of two types. Okay. One is enlargement, one is reduction. Okay. But what, okay, what is that dictates whether it is dilation or enlargement? There is a dilation factor. Dilation factor. What is this dilation factor? Let's see. Okay. Now, I have a triangle. Okay. This is my triangle. My triangle which I am going to experiment. Okay. Now, I have a dilation factor of 2. I'm going to use a dilation factor of 2. That means I'm going to multiply the x with the dilation factor, y with the dilation factor, and determine the coordinate. Suppose dilation factor is 2, then 2 times 3 is 6, 2 times 0 is 0. So 6 comma 0. That is my A dash. This is A, means my A dash is that. Any questions, guys? Any questions?
No.
Now,
Wait, so would you repeat it for all of them?
I am going to apply the dilation factor to both my x and y.
Oh, okay.
Multiply, because dilation factor is the scale factor. You got it?
Would
Yeah.
you do it for the 1, 3, 2 on like the?
Yes. So what would happen? You tell me, Netra.
It would become 2, 6.
Yes, it becomes 2. Say, it becomes, ma, this is wrong, right? This is 3 comma 1, ma. It
Oh.
becomes, yeah, it becomes what? 6
6,
comma
2.
2. 6, 2. So let me write it out. 6, 2. Why is it going there? Wait. 3 comma 1 become, I want to redraw it, guys. 0 0 3 0, wait, 0 0, I really want you to understand, and 3 0, right? And then I also had, I'm going to keep this as 1, right? So this will be 3 comma 1. My triangle of interest is this. That's what I'm going to dilate. This is the triangle I'm going to dilate and check. Dilation means I'm going to apply a scale factor to each of the coordinates. As I said, right, my dilation factor is 2 I'm applying. So what happens? See, for dilation as well, the point of dilation is important. See, point of dilation means you are going to have this point, right? And which point you're dilating? This is the point you're dilating. So draw a line, extend the line, extend that line. So this length is multiplied by 2 and the point is plotted. Make sense, guys? So this is your dilated line. This is your dilated line. So that becomes 6 comma 0. Now for the second thing, second side. This was one of the sides, right? This, you're going to dilate it by a factor of 2. Dilate means you're going to make it bigger here because the factor is 2. Whenever you multiply something by a number greater than 1, it enlarges. So that becomes 6 comma 2. So 6 comma 2 is somewhere here. 6 comma 2. Make sense, guys?
Yeah.
Does it make sense?
Yeah.
Yeah.
Now what happens? This one, the last side, what is this? What will happen to that?
Nothing.
No. Meaning this you did, this you did. So we
Oh.
plotted that. And then this is a straight line, right? Connecting the 2 points, right? So this will become this, right? Make sense? This will also grow double, right?
Yeah.
Yeah, so the size of this will grow double. So that will be the same as this line. Basically, there will be a parallel lines but double in size, right? So now dilated triangle will become this. Any questions, guys? So x comma y, when you dilate it, what happens? You tell me, how does it, what will become of x comma y? It will become, suppose the dilation factor is k. What will happen to x and y?
X times K,
Kx comma
KY.
ky. Did you all get it? Kx comma ky will be the dilated point. Okay, now suppose I, for the point 1 comma 2, apply a dilation factor of half. Is it reduction or dilation?
Reduction.
Whenever you multiply anything by half, right, any number, let's say 4, I apply a dilation factor of half, then the value of 4 reduces to 2. Suppose if you apply a dilation factor of 3, what happens to 4? It becomes 12, it becomes greater than that 4. Original number is 4. You apply a dilation factor less than 1, half, 1 by 3, 1 by 4. Then the value of 4 reduces. So this is reduction. When the dilation factor is less than 1, it's a fraction. Proper fraction means then it is reduction. When the dilation factor is more than 1, then it is enlargement. Any questions, guys? Any questions? Now let me ask you this. In case of translation, rotation, reflection, how do you compare the image and the pre-image? Image and pre-image are
Congruent.
congruent.
Then
This happens in a rigid motion, rigid transformation. The last one is dilation. In dilation, what happens between pre-image and image?
They're proportional.
So
They're
how do you say
similar.
that?
They're similar.
Yes, they produce similar images. Any questions, guys? Any questions on that?
No.
So what and all we have studied? We have literally studied the basics. We have literally studied the basics of translation, rotation, reflection. We have literally studied dilations. Okay. Now, based on the name, right? What is this, guys? This is just conversion of English. You don't need to memorize anything. Please understand, use etymology. Etymology means what is iso, what is metry. What is metry? Metry means
Measure?
some measure. Yeah, good job, Jashvita. What is iso? Iso means same. You said this is measure. Okay, now let me ask you this question. It may look weird, okay, but then when you think about it, you yourself will figure it out. Okay, in which transformations? Let me ask you this question. You're going to answer by yourself. In which transformations isometry is maintained? Isometry is maintained. In which transformations it is not? Tell me. Figure it out, guys. I'll help you. Okay, volunteer, try figuring out, and it's okay to make mistakes.
Not or is it?
Okay, in which it is maintained, I'm asking. Okay,
Okay.
not maintained, we'll write here. Two
Is it
questions are
main-
there. Huh?
They're maintained in rotation,
Maintain in rotation. Okay,
reflection,
reflection.
and translation.
And good job, Johan. And translation. So, in short, what you can say? Isometry is maintained in rigid transformations. Good job. Where it is not maintained?
Dilation.
Dilation.
Dilation, because it produces similar shape. Does it make sense? Okay, last week we studied about orientation of vertices. Remember? A, B, C. Suppose if you reflect it, right? Reflect it on a line. Yeah, you can leave, ma. Reflected on a line means what happens here? If you reflect it on a line, C becomes A. Now both ways you need to write ABC here. If you do this, that becomes ACB. So orientation of vertices. Orientation of vertices means order of the vertices changes where? Order of the vertices changes only in one transformation. Where?
Rotation.
Am I rotating here?
Reflection?
Reflection.
Yeah, reflection. Order of the vertices changes only in reflection. Reflection is the only reflection is the transformation that needs a line of reflection. Dilation needs a point of dilation. Rotation needs a point of rotation. You see what I mean? Meaning, line is the mirror. Okay. For rotation, when you think about it, you always rotate about the origin. You rotate around a point. You dilate around a point. So from the point to the point that's being transformed, you always draw a line. You remember? So here, how do you rotate it? Suppose if this is your point, you draw a line and you rotate this line by 90 degree. Right? So there is always point of rotation, point of dilation. Why point of dilation? Then only you can draw this line and extend it and find out what is the dilated point. Makes sense, guys? Can I stop here? So we studied nicely in detail, but I don't know. Meaning the thing is, you should be able to remember the rules. X comma y, meaning for everything you need to remember the rules. For translation, x comma y becomes x plus a comma y plus b. A can be positive or negative. This is translation. Like this, you need to remember everything. We'll finish with this. Reflection, what happens? X comma y becomes, see, it depends on the way how you are going to reflect. Suppose if it is on the x-axis, this becomes x comma minus y. Suppose if it's reflected on the y-axis, it's a line of reflection, right? X comma y becomes, y-axis means minus x comma y. Y equal to x line means x comma y becomes what happens here? Just switches, right? And then switches and negates, right? Y equal to minus x. Similarly, for rotation, there's a long one, right? 90-degree counterclockwise is the same as 270-degree clockwise. X comma y becomes minus y comma x. Similarly, 180-degree counterclockwise is the same as 180-degree clockwise. X comma y becomes what, guys? What did we learn? Minus x comma minus y, right? Last one, 270-degree counterclockwise or 90-degree clockwise will become x comma y goes to y comma minus x. Dilation, the last rule is both enlargement or reduction. X comma y becomes kx comma ky. Any questions, guys? All these you will memorize. That's all from me. If you have any questions, stay. If you don't have any questions, I'll give you homework on dilations and rotations. Any questions, guys? Please do the homework and come. I'll stop here. Have a nice week ahead, guys.
Bye, Miss
But
Priya. Thank
Bye.
you.
Bye,
get
Miss
into
Priya. Thank
statistics
you.
next week. Bye, ma.
Miss Priya.
Bye, ma.
Wait, Miss Priya,
Yeah, I'm here.
can I talk to you for a second?
Absolutely, Naman. Yeah, I want to do you on the video, you know.
Yeah. So since I wasn't here, do you think you could give me like the recordings for the past videos?
Past videos, na which one, ma?
Like some videos, because like there's only videos for like the second half. There's not the videos for the first half.
First half of grade 7 now.
Yeah.
Are they helping you, Naman?
Yeah, I'm understanding it.
If you look through the video, you're understanding it?
Yeah.
Okay. I would really like to help you, but I want you to help me out too. Can I ask you?
Yeah.
You know how I'm going to ask you to help me? Let me
No.
first stop the recording.